During the walkthrough survey, commonly known as the property inspection, inspectors are going to run into transformers. Transformers are necessary when there's a higher voltage in the building and lower voltage is necessary. For instance, running these lights requires a lower voltage than the 480 277 being provided to the building. In that case, that would be a step-down transformer. If we had a lower voltage, for instance, 208 120 or 240 120, sometimes a higher voltage is needed, and that would be a step-up transformer. A transformer works by having a series of coils around a magnetic core. The number of coils around the core will create a magnetic field. If the second core is placed next to the original core, the energy from the first core is transferred to the second coil. Depending on the number of turns on each side, increases or decreases the current. If the primary coil has less turns than the secondary coil, then that is considered to be a step-up transformer. If the primary coil has more turns than the secondary coil, then that is a step-down transformer. These units produce a tremendous amount of heat during their operation. Modern units are typically air-cooled, but older units are actually oil-cooled. The transformer does not require maintenance and therefore does not require direct access. These are often found hanging from supports high up in the ceiling of the structure as well. Inspecting transformers can involve going into a specific room, like this electrical closet. It could be anywhere in the building. These could be located up high, which we have a couple in this room that are high, or they could be located on the ground. But let's walk through the inspection of this transformer, noting the fact that these are very loud. And so our audio is going to have a little bit of muffle because I have 5 transformers located in this small electric closet. Before you do anything to your transformer or part of any type of the inspection, begin with identifying the label plate. When I look at the label plate, I'm going to see on it whether or not the primary voltage is higher than the secondary voltage, or if the secondary voltage is higher than the primary voltage. If the primary voltage is higher and the secondary voltage is lower, that is a step-down transformer. If the primary voltage is lower and the secondary voltage is higher, that is a step-up transformer. The inspection of a transformer is not necessarily listed in the COMSOP, but it is part of the electrical equipment. So let's go through the inspection process of every transformer. First, because it is part of the electrical equipment, it does have the same 30 by 36 by 78 rule. So do I have 30 inches of clearance? So this, yes. Do I have 36 inches of clearance front to back? Yes. And do I have 78 inches of clearance above? Yes. Once I've established my working space, then I can look at dedicated space. And remember, dedicated space extends at least 6 foot up or through the structural ceiling. And in this case, all the way up through the structural ceiling, I do have proper dedicated space. After establishing dedicated working space, I will photograph every transformer. Just the front of the transformer is all that's necessary, unless I had a deficiency in working or dedicated space. Then I will take a photograph of the label plate to identify whether it's a step up or step down transformer. If it's a step down transformer, then it's providing current to something else that requires less current than I had. If it's a step up transformer, then it's increasing the current to operate something downstream that requires additional current. This is an air-cooled transformer. Again, it's making a lot of buzzing sound. It does produce some heat, but what I'm identifying next is our conduit. Our conduit needs to enter and exit the transformer at the bottom third of the unit. It's at the bottom third of the unit because of the heat. We don't want the conductors up high above the coils because they can melt. If they're down low, they're below the coils and entering through the coils at a lower height. The conduit needs to come from a supply box, so I need to identify the incoming current, which would be this panel, and then identify the outgoing current, which will be this disconnect. So identifying the incoming current, I need to inspect this panel. Verify that it does not have any stray current by using my right hand, opening it up, and identify the breaker that is servicing this transformer. This breaker is here. It is a three-phase, 125 amp, 480 volt breaker. The conductors follow through this conduit into the transformer. The transformer, being a step-down transformer, releases, instead of the 480, it comes out at 208, 120, through this conduit, through this disconnect. From this disconnect, it's providing electricity through conductors and this conduit to this electric panel. Before opening this panel, I verify it does not have current by using my right hand or a non-contact voltage detector. Again, hair on my knuckles would stand up or I'd feel static. And this panel is labeled lighting panel, and it is rated at 208, 120. Its main disconnect will be located in the disconnect that we have next to the transformer, and it is servicing that panel. During your inspection of the transformer, you're going to identify any physical damage, any burn marks, or anything that might be noteworthy or important for your client, notwithstanding what dedicated space and working space. Imagine with the heat from the transformer, this is an excellent spot to keep your lunch warm. And this is something that should never be present on the transformer. So it's important that you identify those things for sure during your inspection. Not all transformers are conveniently located like this particular transformer is right here on the floor. Some could be small lighting transformers that could be mounted on the wall, and some transformers could be located very high up on the ceiling or in pillars. Again, these do not require maintenance. They just are there to access and either step up or step down the current. And so it's important to identify all the transformers in the building. And again, regardless of what type and where they're located, we're going to look for working space, dedicated space, and attempt to identify whether they're step up or step down. The ones up on the ceiling may be more difficult than others, but we want to try to trace the conduit and identify what they are providing.